everyone. My name is Zuri. I'm working with Dr. Yu Ping Sun in plant science and at Utah State University. So that plot and also this plot is my project. So this plot, I'm more focused on the 3 penstemon species in the field, not all of it. That's why I just present 3 species here. So as we all know, Utah is a very drought state. But also at the same time, 70% of residential water use is just for landscape watering in the western United States. That's the first why we did this project. So for the method and the materials, you can see there's 3 lines here. This line is 20% of evapotranspiration, which I call it low treatment. This one is 50% evapotranspiration. This one is 80%. So the evapotranspiration is the water loss from the soil and also from the plant surface. Here is the result. So the orange line is the ET. I collect the every day from a weather station, and the black one is the precipitation we got from the last year. Those 2 posters all from the last year result. This year is still like going on. And from the figure, you can see we have a lot of raining last year. And if you remember, we also got a lot of snow last winter. So that's maybe the reason my result is not that significant from last year. And so here is the deficit irrigation result. 80%, 50 and 20%, which is high, medium, and low. I turn on the irrigation for 6, 3, and 0 time for the treatment. And here is the part of the result I put on the poster. The first one, figure A, is the overall appearance. If you remember, you did the rating for the vines. There's the last column is called overall appearance. So 0 is dead plants, 5 is perfect, 3 is kind of like in the middle. It's healthy plants. And so from the result, you can see there's not much difference from the treatment, because from this figure you can see the low treatment, which is a red line, is in the middle of the high and medium treatment, which is definitely not from the treatment because it's not getting any irrigation at all. So we did the stoma conductance for all the plants, but we did not put on the poster because you can see this species have very tiny leaves. So we could not take stoma conductance for this one. We only did for that 2. What I put on the poster is the canopy temperature. I hold a thermal camera here and take a picture and analyze later to get the canopy temperature of the plants here. So from figure B, you can tell it's a slightly different. The high frequency, which is green color, is at the bottom, slightly different, but not significant. So this poster is from that plot. I focus on all the plants in this plot. I have like 11 species. So the reason I did it, the method and also the weather is the same treatment, but different plants. I did a cluster analysis for all the plants in that plot. These 4 species did pretty good during the cold winter last year, which is miscanthus, that is the grass in the plot, and Diablo, little devil. The Diablo is the bigger plant with purple leaves. The little devil is the small plants with purple leaves. And rose is very easy to tell. Those plants did very good during the winter and also during the summer. The last 4 column in this figure is the overall appearance of that 4 species. So during the whole growing season last year, even under the low irrigation frequency, it's still like about 3. So it's a healthy and a nice plant, at least in average. And here is the stoma conductance. I did not show the canopy temperature. I want to diversify a little bit. So the stoma conductance, you can tell the high frequency has a higher stoma conductance in the figure. This one, the last one, is because I always took the data at the end of the month. So at the end of the August, it's very cold already. Plants close the stoma, like prepare for the winter. That's why like showing almost all the 0. So that is all the result I present in the poster. Is there any questions? Or you can feel free to walk inside those two plots, take a look. We have labels, small labels in front of the plants and say what is species and also the plant location if you want to take a look.